Thank you very much. Welcome, everybody. My name is Alan Stein. I'm a senior research fellow in global health and public policy here. And it's an absolute pleasure to welcome Clayton Aldern. Clayton's going to talk to us about his book, this wonderful book, which you can see, The Weight of Nature. Clayton will give us a few introductory remarks, and there'll be a chance, and we'll have a bit of a Q&A, and then afterwards, there's drinks outside. Just to say a few words about Clayton, he's a neuroscientist and a journalist, and he did an undergraduate neuroscience degree at Brown, and then he came to the NAFA Department of Clinical Neurosciences here and did some very interesting work on computational modeling around Parkinson's disease. And then he came down the road, as it were, to join the Masters in Public Policy here, which he finished some while back when we were still down in the old building. This book is really a remarkable book, I have to say, and for anyone who hasn't read it or looked at it just yet, I would really recommend it. It's a real tour de force. In some ways, it's a non-linear, almost novel type, but it's not. There's nothing fiction in here, but beautifully written about a tour through all sorts of aspects of his discoveries around the impact of climate on brain and brain functioning. Really taking us all the way from Descartes to Obama, who doesn't come off that well, does he? And then Damasio, who's a very well-known neuroscientist, and all sorts of interesting anecdotes about bullfighters who trip because of the temperature, and other studies on, for example, soldiers who struggle to read Morse code as the temperature increases, and the greater the increase in temperature, the poorer their functioning. And it just takes us through a real tour de force through all of that. Clayton's also written a whole lot of other things as a journalist and as a writer. He wrote a very interesting book on homelessness with another colleague, and really going to the science of why homelessness clusters in various cities. And again, a very interesting book. But anyway, I strongly recommend this, and a wonderful book. And really, I only picked it up and received my copy 2 days ago, but I thought, well, I'll just have a quick skim through something. But actually, uncommonly for me, I managed to get through the whole thing before today. It was really excellent. So Clayton, do you want to go ahead and just give us a few introductory remarks?
Yeah, I'd be happy to. And thanks again so much for having me. As Professor Stein mentioned, I'll just sneak past you. When I did the MPP at Blavatnik, this building was still under construction. So it is quite the pleasure to be back in such a beautiful space, and to see such friendly faces in this beautiful space. I'd like to just begin with a couple-minute reading from the text. Usually when I talk about the material in this book, I'm speaking directly to the science and to some of the neurophilosophical underpinnings of these intersections, which we can spend some time on that. But seeing as I'm in a school of public policy, I thought I could speak directly to some of those implications. So here are a few minutes on that, and then I'll offer a few remarks. This is from a section on infectious disease that affects the brain. As we see climate beginning to change, the habitable range of organisms like ticks and mosquitoes indeed begins to broaden. These are vectors of very specific brain diseases, right? Including yellow fever, dengue, cerebral malaria, all the kind of stuff that you kind of don't want to have a doctor diagnose you with. And so I'm gonna read a section from that chunk of the book, which is on rabies. So this is me being introduced to a man named Ryan Wallace. The first federal Van Helsing I meet is named Ryan Wallace, a veterinary epidemiologist who leads the rabies epidemiology team at the CDC. His team sits within the pox virus and rabies branch, which itself resides within the division of high consequence pathogens and pathology in the Center for Emerging and Zoonotic Infectious Diseases, one of the centers to which the Centers for Disease Control and Prevention refers. He also runs the CDC's World Organization for Animal Health Reference Laboratory for rabies. Wallace conducts rabies research in dozens of countries and has participated in the vaccination of hundreds of thousands of dogs. He is the rabies guy. Vampire bats are not the villains they're often made out to be, says Wallace. They are a study in resilience and ingenuity. Desdemodontidae are perfectly adapted to nocturnal life, with bodies streamlined like whispers and wings that beat with a silence that is as awe-inspiring as it is eerie. They navigate a world almost entirely unseen by human senses. It is merely their food, their affinity for the blood of other mammals that casts them in an uncanny light. Razor-sharp incisors evolved to precision pierce skin with a surgeon's finesse. The bitten are often oblivious. Bat saliva, a cocktail of anticoagulants, ensures a steady flow of blood. Perhaps even more intriguing is their social fabric. Vampire bats, contrary to the common solitary image, are deeply social creatures. They dwell in roosts bound by ties of kinship and cooperation. Mothers care devotedly for their young, siblings share in duties, they exhibit altruism. They share meals. Their roosts are social networks built on bonds that endure across time. Accordingly, the climate theory of vampire rabies looks something like this. Vampire bats are living beings with a complex ecological role. Their existence is interwoven into a delicate balance of ecosystems, but with the ebb and flow of climate change, the animals face a double jeopardy. Capricious weather patterns and warming temperatures affect both their roosting sites and the prey upon which they subsist. Vampire bats are climate refugees too. And as they are forced from their traditional grounds, the rabies virus rides along with them. When I asked Wallace about the degree to which climate change realistically bears on rabies risk from vampire bats, he tells me that the story is unsurprisingly a complicated one. We're watching vampire bat rabies that is found in all of South America, Central America, and Mexico, he says. The vampire bat home range is theorized to become more favorable in the southern United States, namely Texas and Florida, over the next 15 or 20 years due to climate change. But he's also quick to point out that just because they might soon have a more favorable habitat doesn't mean the bats will necessarily take up residence in the United States. Hence his surveillance apparatus. Wallace's team is tracking vampire bats using everything from citizen science apps like iNaturalist to communiques from the Mexican public and animal health programs. He is concerned enough to be keeping a close eye on the matter. Vampire bats aren't really keeping Ryan Wallace up at night, though. Unlike the case of something awful like primary amoebic meningoencephalitis, we have a vaccine for rabies. Like many vaccines, it doesn't just offer us a shield against the rabies virus, it gives our bodies the tools to forge their own. Wallace has dozens of examples of successful rabies vaccination campaigns. Instead, his midnight climate worries are all about resource constraints. From his perspective, it's already incredibly difficult to get governments to prioritize rabies. If we as a rabies community have to compete with food scarcity, natural disasters, increasing political turnover, and other challenges that are all going to be exacerbated by climate change, rabies will fall far, far down on the priority list, he says. And I think there are certain countries and certain regions where it's going to make it incredibly challenging to see progress. In other words, Wallace's concerns look more like the Pentagon's than they do that of a climate scientist. And it's in this manner in which a changing climate acts on social forces that is most concerning. Rabies vaccination programs are largely sponsored by governments. These programs work, he argues. With well-operated programs comes a corresponding drop in rabies incidence. But if you don't have a functional government, he says, you're not going to be good at getting money for a neglected disease program. You're not going to be very good at implementing logistically challenging mass vaccination programs. So Wallace is a great example of somebody who, in my research, I think is thinking about both the direct and indirect impacts of a changing climate on brain health and the public policy implications in question. I spoke a little about infectious disease. Rabies is a great example. But a changing climate is going to wreak much more havoc on brain health than just via these disease vectors. So by way of example, as extreme storms tend to loose something like synthetic fertilizer from large agricultural operations into streams and rivers, this nitrogen-rich fertilizer flows into water tables and tends to fertilize everything it touches. So this includes organisms like cyanobacteria, right, blue-green algae. As blue-green algae is fertilized, it blooms. You may be familiar with these large blooms in freshwater systems. And as warming waters continue to support these colonies, we tend to see an increasing size and frequency of cyanobacterial blooms all around the world under a warming climate. What do we know about cyanobacteria? They release a neurotoxin. What do we know about the neurotoxin in question? Unfortunately, it's likely airborne. And if you look downwind of cyanobacterial-rich waters and conduct some kind of neuroepidemiological study, you see a risk of something like ALS, right? Amyotrophic lateral sclerosis, also known as Lou Gehrig's disease, motor neuron disease. You see a risk of ALS, this horrifying neurodegenerative condition, of about 10 to 25x what you would expect, all else equal. So it's not just disease vectors per se that are being exacerbated by a changing climate. It's also direct neurotoxin exposure that's being exacerbated by a changing climate. We're also seeing something similar with methylmercury releases in warming waters, right? Because fish that are exposed to methylmercury in the water, we know, for example, that we're not supposed to be eating too much fish because of potential mercury exposure. All of that has been relatively well controlled up until now, ever since we've put global rules on mercury. This is the Minamata Convention. But unfortunately, we're seeing more global flux of mercury flows released from ice sheets in Greenland, flowing into, again, the sea and ultimately in brackish waters as well. It bioaccumulates in fish who, in warming waters, need to swim faster and collect more nutrients. Thereby, the biomagnification is increased, and we can expect to see more methylmercury exposure in people who are the next up the food chain going forward. So this is additional bad news on the neurotoxin front. But neurotoxin exposures in infectious disease are not the entirety of the story here. I mentioned that one of the things that I appreciate about Wallace's perspective is he's also paying quite close attention to some of these indirect effects. What I mean by indirect effects on health and on health economies and on the relationship between climate and public policy is, for example, the manifold manners in which a changing climate, whether through heat or air pollution or increasing ambient carbon dioxide, bears on brain health by way of low-level inflammation and the scattering of functional brain networks that effectively result in more impulsive behavior. We have dozens and dozens and dozens of examples of this kind of thing playing out. You may be familiar with the evidence that suggests, for example, that people are more aggressive in the heat, right? We know this to be true at the individual level. We know it to be true at the city level, intra-city level, intra-city level, national level, international level. Effectively, when temperatures rise, violence rises in kind. You see more incidents of domestic violence in the household. You see a rise in online hate speech incidents. There's a corresponding rise in suicide at higher temperatures, right? And then again, this is not just the fact that you can compare somebody living in a cool place to a warm place and expect to see some behavioral difference. This is talking about within a given area, deviations in what is considered to be normal for the climate, resulting in neurocognitive and behavioral effects thereof. It's true, for example, that immigration judges on hotter days in the United States are less likely to side with asylum applicants who appear before them, right? Canadian members of parliament's speeches are less complex at higher levels of ambient particulate matter. It's also true that chess players, for example, aren't as good at playing the game in question when they're exposed to higher levels of air pollution. Pitchers in baseball are more likely to hit batters of the opposing team intentionally with their pitches on hotter days, right? In the US Postal Service, we see an increase, for example, in incidents of racial discrimination, sexual harassment, union grievances, and this is true both of outdoor workers and indoor workers, right? People delivering mail and working inside the air-conditioned buildings themselves. Why the Postal Service? Why do we care about it? Basically, this is just because it's the largest public workforce in the United States, so we can get good data on it. And when we look at those data, correcting for socioeconomic conditions, correcting for interregional variation, correcting for any kind of geopolitical or socioeconomic variable under the sun, we still see this marginal effect of temperature on behavior. And what the neuroscientists would say is that in part this is true because when you zoom in on the brain in heat, there are a couple things going on. The first is that we have a fixed cognitive capacity insofar as it takes physical energy, right? It takes metabolism, it takes metabolic energy to produce the outcomes that the brain produces all day. And at higher temperatures, some of that metabolic energy needs to be allocated to the cooling of that brain matter, because your brain really only tends to operate well within a very narrow thermogenic window. And so at these higher temperatures, when you have to devote effectively more and more comparative thermal effort, right, metabolic efforts to cooling the brain, you have to sacrifice something, right? What gets sacrificed? Well, because you're focused on the more fundamental work of keeping yourself alive, almost by definition, what you're sacrificing cognitively are the most evolutionarily new rational executive function behaviors, right? The stuff that's happening in the newest of the new cortex. It's a region called the dorsolateral prefrontal cortex. And at high temperatures, we see, in particular, it's this region that's overworked. And it's this region that becomes less functionally connected to the rest of the decision-making machinery of the brain. So what happens when your dorsolateral prefrontal cortex is overworked? It means that your decision-making centers, the rest of that prefrontal cortex, tend to have outsized influence over the DLPFC. What's going on in those decision-making centers? You've got regions like the ventromedial prefrontal cortex, which receives inputs from your emotional brain. This is the limbic system, stuff like the amygdala, which you perhaps have heard of, heavily emotionally attuned both to the environment and to your body. And so if your dorsolateral prefrontal cortex is overworked, and your limbic system is offering undue influence onto this decision-making center in your brain, what are your decisions going to look like? They're going to look less rational. They're going to look more emotional. You're going to be making impulsive decisions. And psychologically speaking, behaviorally speaking, it is impulsivity that leads to something like the interpretation of an otherwise benign interaction as aggressive. It is that which causes you to respond aggressively in kind. It's also the kind of impulsivity that, for example, leads to students who take exams on hotter days, receiving comparatively lower scores relative to how they had done previously on temperate days, right? There have been dozens of these types of studies conducted around the world where you compare a student to herself at different points in time on similar exams at different temperatures. And at higher temperatures, again, correcting for every socioeconomic variable under the sun, you see this corresponding marginal drop in performance as a function of temperature. So in terms of indirect effects on economies and global productivity, right, and the flows of capital that arguably public policy practitioners tend to be paying attention to, we see this pathway that we can trace from climate change through to behavior, through to, at the population level, downticks in productivity, downticks in per capita GDP, downticks in education attainment, right? For example, in the United States, we know that there is a racial achievement gap among people with different races and ethnicities. And much of that can be explained by various sociodemographic factors, right? Various models that statisticians who pay rigorous attention to this kind of stuff can pin to the social environment, the cultural environment, right? All the adverse childhood experiences that stem from growing up, for example, in poverty or surrounded by crime, et cetera, et cetera. And yet, when you correct for all those effects, you also see something like the disparate distribution of air conditioning in schools that various students attend. And if you ask, what is the marginal contribution of the presence of air conditioning to educational attainment alone, it explains something on the order of 5% of the racial achievement gap in the United States. So my point is these effects add up. And I would argue that at a public policy level, when we think about climate change, when we think about the types of cost-benefit analyses that we as climate policy analysts are engaged in all the time, the types of climate economic experiments that folks are engaged in all the time, we're ignoring a large piece of the puzzle when we choose to ignore the neurocognitive effects of a changing climate. So that's the premise of the book, and ideally the premise of the remaining, 35 minutes or so of this conversation. So yes, thanks so much for listening to me babble on a bit.
Great. Thanks. Really fascinating. Perhaps you could just say something about, you touch on the issues of epigenetics, because obviously that might be one way in which climate affects, in a tangible way, affects cell function. And perhaps you could just say a little bit about that and the stress, the pregnancy and stress study and a few others.
Yes, happy to.
And perhaps just might be worth, I'm not sure, for everybody to be familiar with epigenetics, explain just the mechanism would be really helpful.
Sure. So you'll note that none of what I just said had anything to do with quote unquote mental health, right? It's becoming more and more commonplace these days to indeed relate climate change to public health, and in some circles relate climate change to mental health. The very, very real relationships between a changing climate and the incidence of anxiety, depression, post-traumatic stress, for example. It's extremely violent to experience a hurricane or a wildfire, and unsurprisingly, we see prevalence and incidence of something like post-traumatic stress disorder rise in kind with proximity and severity of exposure to natural disasters. So the mental health burden of climate change is almost unfathomable. And there's a bit of that in the book, and I'm glad that it's part of the public policy conversation to a certain extent. It's not the primary focus of this text, but it becomes related to the primary focus when we start talking epigenetics. So what is epigenetics? These are modifications to one's genome that occur as a function of environmental interactions. They do not result in genetic mutations. They do not change your genes. Epigenetic changes tend to amount to something like a given protein, a given molecule in your body, resulting in a kind of conformational change on top of DNA that flicks a gene on or off. And so because of that, you see variations in levels of protein expression that the genes code for as DNA does what it does, as it produces through your various genetic processes all the cells in your body. Now, notice that I mentioned that epigenetic factors have this intimate relationship with environmental interactions, right? It is in fact, the method by which, genetically speaking, the changes in the environment that we experience are integrated into our genome. Epigenetic changes, while they do not, again, introduce mutations per se, epigenetic changes are in fact heritable as well, just as our genes are. So the study that Professor Stein mentioned makes some of these environmental epigenetic changes very, very tangible as they relate to mental health. So by way of example, in 2009, a researcher at New York, City University of New York, I think, named Yoko Nomura, she's a neuropsychologist, had collected a cohort of 400 or so expecting mothers, right? And she was running what was called the stress in pregnancy study. And it was an attempt to trace the experience of mothers and their children in the first decade or so of the children's life as a function of environmental stress. And again, this is the environment writ large. We're talking about everything from noise pollution to crime rates, to the structure of one's family, to the types of light bulbs you have in your house, to indeed other common stressors like whether or not there is drug use in your family, or the income that a given set of family members may have, right? Everything that may affect these adverse childhood experiences, how those experiences are related to maternal-child health outcomes. So she's running this study, and in 2012, Hurricane Sandy hits New York City. This is a massive climatological event, billions and billions of dollars of damage. And she's already got this cohort of expecting mothers. And she realizes she has this natural experiment in front of her. She splits her cohort into two groups, one of which is composed of children who were in utero during the storm, and the other of which is composed of children who were either born immediately before the storm or indeed conceived after Hurricane Sandy. And she follows these children for 10 years. And in 2022, the initial findings of the stress and pregnancy study as a function of Sandy come out. And what she shows is as early as preschool, relative to those who had not experienced the storm in utero, children who had experienced Sandy were at drastically increased risks of neuropsychiatric conditions like anxiety, depression, ADHD, various conduct disorders like defiant disorders, right? And when I say drastically increased risks, I mean girls were experiencing anxiety at rates 20x that of their cohort in the non-exposed group. 30x rates of depression, right? Boys, again, we're talking as early as preschool, had rates of ADHD, 60 times that of those who'd not been exposed to the storm. So right, this is shocking and should concern us at a global public policy level, because we're only going to see more and more of these storms at a greater and greater frequency over the coming decades. And we may ask ourselves, well, how on earth does this happen? How is it that a single climatic event can lead to such a drastically outsized risk of a neuropsychiatric condition? And Dr. Nomura's answer is epigenetics, right? Because what's happening in the womb is, as a fetus, of course you're exposed to hormones, for example, that your mother is releasing during stress. And at low levels of exposure, stress can actually be a somewhat inoculating force, right? Because we want to have some sense of what the world is like as fetuses. We want, when we're born, to have some sense of a relationship between the environment as it exists and what an appropriate response to that environment looks like. And sometimes the world is stressful. And so as mothers have these glucocorticoid responses, right, release something like cortisol, right, the stress molecule, and it crosses that placenta and influences the neurochemistry and indeed the methylation profiles, right, the epigenetics of the fetus in question, you're adjusting that future infant's stress profile. You're adjusting their stress response. So they are indeed perhaps well adjusted, or with no exposure, perhaps unadjusted to future stressors. The problem is, if the mother in question experiences such an extreme event, a hurricane being a good example, everybody has a breaking point, right? There is a point at which, as a fetus, too much cortisol, right? A great enough glucocorticoid response in the womb will effectively offer a maladaptive stress response. And this, as manifest in behavior, looks a lot like the neuropsychiatric conditions that we've observed in this cohort in particular. So it's some concerning research. And I think in terms of the ethical implications should concern us at an even deeper level, because we're talking about people who, for example, had an exposure to a climatic event that they weren't even born for, that is then setting them upon a different life trajectory. And this is kind of the classic story of climate change, right? Those who are least responsible for the problem are going to be those who kind of bear the brunt of the crisis around the world.
Can you say a bit more how much that's been replicated, those sorts of findings?
Yeah, so we see, this is, the kind of niche field that describes the neuroscience of intergenerational trauma. We see similar findings in Holocaust survivors and their offspring, in descendants of those who experienced slavery, in descendants of the Rwandan genocide. It is kind of widely acknowledged, both anecdotally and in terms of the neuropsychiatric outcomes in question. There's much less research on mechanism, right? So her statement about epigenetic transfer, for example, is somewhat speculative. She has some evidence that would suggest it's the case. But what we do know is that trauma appears to be heritable in a way that we otherwise perhaps expect it would not be. We have animal studies that epigenetically show this is true, right? If you expose a mouse, for example, to extremely stressful conditions, and create an environment in which it is, as an expecting mouse mother, made to fear something like a tone, for example. It will be true that the offspring of this mouse will also fear the tone in question, despite, of course, never having actually experienced it while it had 4 feet on the ground. So animal models would seem to point in the same direction. Stories from other extremely traumatic events would seem to support the suggestion. But in terms of climatic stress in particular, offering a heritable epigenetic change that is predictive of neuropsychiatric trauma, this is new research. Yes, it's really the first of its kind that offers this kind of longitudinal approach. And one of the reasons that's true is because this is an extraordinarily difficult experiment to design, right? You can't just selectively expose a bunch of expecting mothers to a hurricane and say, well, we're going to watch what happens. And even if you could gin up a hurricane and say, well, we're going to create some extreme weather and then randomize the exposure rates of this extreme weather to a handful of cohorts, it would be deeply unethical. And so researchers interested in this kind of thing kind of have to wait around with their hands in their pockets for a natural experiment like Dr. Nomura's to come along.
Great. Perhaps I can just ask one more question and then I'll hand over to the audience. I mean, as a school of government where public policy is big, I mean, governments are hard to persuade and many of them are rowing back on their obligations or on their commitments, and COP28 wasn't a roaring success. So is there one thing that this research, the brain research and climate, that you could use to that you would take to a government and say, this, you need to think about this, that would convince them, or one thing you would like them to do that's in addition or different to what they're doing already?
Yes, I would say that currently climate policy, as I think we've begun to suggest in this talk, is predicated on cost-benefit analysis, right? The climate and the climate solutions investments that governments make, right? Whether in terms of procurement decisions or in terms of agenda setting, right? The decisions that governments make about climate action, of course, by definition, are predicated on the extent to which the benefits of those investments can indeed offset the costs. And it's an important conversation because the costs in question are quite high, right? Climate action is expensive. It's becoming less expensive, but it's still expensive. And so I think it's quite important that we are accurately accounting for the costs of the climate crisis writ large. That, to me, includes the public health costs thereof. And right now, when we talk about morbidity and mortality costs of climate change, all of those models that illustrate the relationship between climate change and public health, basically based on mortality and morbidity estimates that were created in 2003, by a brilliant epidemiologist. I'm glad he did this work. But it's basically, what is climate change going to do to malaria? What is it going to do to respiratory health, cardiovascular health? There are no current estimates that link climate change to non-malarial infectious disease, right? Any of the stuff we talked about at the top. And there are certainly no cost-benefit analyses or climate economic models or public health models or anything of the sort that relate climate change to the productivity costs, right? The lost education costs in question, the productivity as not just related to education, but indeed the workplace, the costs of aggression, right? Violence is a very real cost on society. And again, we've just begun to scratch the surface here. We haven't talked at all, for example, about the relationship between air pollution from wildfires, for example, and risk of neurodegeneration, right? Risk of neurodegenerative diseases like Alzheimer's and Parkinson's and various forms of dementia, right? There's a whole swath of neurological conditions that are indeed affected by the vectors of climate change, and I think, are wholly failing to price them as we think about the necessity of climate action. I think it's much easier as a government to make the case that climate action is warranted if we are counting for more wholly the costs in question.
Thanks. Let's turn it over to the audience. Can we just start just behind you and then and then we'll come to the front. Thanks very much. Could you just say your name and...
Thank you. Hi, I'm Kate. I'm just a resident. Exactly on that point, how on earth did you choose what to include in the book and not get sucked into what sound like sort of separate books on each of those topics? What was your sort of process of categorizing and prioritizing?
Yeah, thanks. You'll note that, again, I tend not to spend much time on mental health per se, for example, which is not to suggest it's not important or not real, but to me, most of the mental health conversation as it relates to the climate crisis is a function of our discussions around what's called climate anxiety or eco-anxiety, right? The notion that for some, the kind of fear of or worry about this impending crisis, is enough to constitute whether an isolating set of behaviors or a quite borderline clinically anxious set of behaviors. And while these effects are real, to me, they do not constitute the direct action of climatic change on the brain per se, right? It is a response to thinking about the climate crisis. You are worrying about climate change, not necessarily being directly influencing your behavior by the vectors of climate change. So the scope of the book is the latter chunk. I seek to illustrate all the manners in which environmental degradation and environmental fluxes as embodied by climate change bear directly on brain health. And so for me, that includes behavioral aspects, including cognition, aggression. It includes somewhat of the more tangible infectious disease aspects and the traumatic aspects that we just touched on. And then it includes some subtler forces that we didn't have time to discuss in this talk. All the manners in which, for example, ocean acidification bears on sensory systems, right? The degree to which marine animals can hear and smell in the water, right? The chemosensing that many marine and terrestrial animals necessarily need to engage in to navigate their environments, because these sensory systems, and likely our own as well, are based on the ability to recognize various molecules in our environment. As the climate changes, there are very specific chemical interactions between things like carbon dioxide, right? This, which is a very acidic molecule, and the molecules that we need to sense to navigate the world. So there are these sensory impacts. There are impacts on linguistics that we can talk about maybe out in the reception later. But again, I would consider those to be important direct relationships between climate change and cognition, brain health, decision-making, behavior. This is really a story of all the manners in which the climate crisis is kind of changing us, from the inside out.
Right, thanks. Just the front, and then we'll go to you in the second row.
Thank you so much already. My name is Jasmine. I'm a default student here. And I'm wondering, in behavioral economics and behavioral public policy, we often try to find ways to help people get to where they want to be, which, often includes trying to act more rational, or in today's world, I guess, often addresses to reduce stimulation, deal with very limited attention, et cetera, et cetera. Now, I don't know the numbers, but it sounds a bit to me that something like this, climate heat, could almost immediately nullify a lot of the little gimmicks that we have found up to now, or just make them not really work anymore because cognitive function is reduced so much. So in this space where it already feels like cognitive capacity is so limited, and also already unequally distributed because of the effects of poverty on cognition, et cetera. Where would you even start to deal with that problem? How do you address an environment where it seems that cognitive capacity keeps decreasing when
Yes.
you want to keep increasing?
Yes. I think that there are some technological solutions that are worth talking about. There are some urban planning solutions that are worth talking about. And then there are just, perhaps behavioral economic solutions, those types of personal changes that are worth thinking about, the nudges that are perhaps worth thinking about at a slightly subtler level. So just to briefly take those in turn, provision of air conditioning really matters. Provision of air filtration systems really matters, right? Encouraging, from a public health perspective, people to wear really serious masks when there's wildfire smoke really matters. Masks are indeed quite neuroprotective in the face of particulate matter, right? So technological stopgaps do work wonders, and it has been shown that provision of air conditioning, for example, can correct some of the effects in question. Now, the problem there, of course, is that given the distribution of the global energy mix, air conditioning is only going to continue to exacerbate the climate problem. So you have this trade-off between kind of short-term benefit, right, short-term neuroprotection, and long-term climatic health. As Solomon Shang, who's a climate economist at Berkeley, would say, right, we could give everybody spacesuits, right? We could protect people in terms of these adaptive profiles to the extent that we'd be able to survive the harshest environment ever. But then we wouldn't have any money left over once we're zipped up in the suits. So the cost benefit analysis there really matters. Which brings me to the kind of urban planning decisions that feel useful, right? We spent a lot of time this evening talking about some of the harms that environments can perpetrate on neurological health. But actually, environmental interactions writ large often offer a suite of neuroprotective benefits, right? We know from a similar literature that exposure to green space really matters, right? There's a reason why forest bathing, for example, is considered to be so neuroprotective, right? Provision of trees in urban cores can indeed directly enhance one's neurocognition. We see life expectancy differences. Again, correcting for other demographic and socioeconomic factors, we see life expectancy differences between parts of cities with high tree cover and parts of cities with low tree cover. So density matters, tree cover really matters, right? The way that we design our cities and the built environment, I think, is an important part of this conversation. On the personal front, on the behavioral economics front, it's a somewhat complicated story, but I think we can draw some lessons, for example, from neuropsychology. We know that much of what we're talking about right now is about this kind of intimate relationship between environment and self, and the almost loss of free will that we experience under these various environmental conditions, right? If the environment is kind of reaching in and influencing your proclivity toward aggression, right? Where's the free will in that decision? You're almost losing some agency. But we have lots of great neuropsychological tools for confronting those kinds of low agency moments, and these include cognitive behavioral therapy. They include things like mindfulness, right? Mindfulness, I think, for example, is often discussed in this kind of new age or highfalutin tone, but the neuroscience of mindfulness would suggest that these practices of mindful presence, of acknowledging the state of one's body and one's emotional responses, and being able to name this experience, but then move on and name other experiences that one has, they really matter in terms of restoring the kind of functional connectivity between the relevant brain networks in question. So I would advocate for effectively, a certain kind of climate therapy that you may not need to interact with a counselor to undergo, but principles of which you may be able to apply to your own psychological and biological resilience going forward. So I think it's all these things. And you asked me at the end of your question, where do we start? I don't know. And in part, I don't know because this is a tremendously new field. I have kind of a pet project here in attempting to unite what I view as, relatively disparate fields of research into a unified research agenda. So, I have a name for this field. I would call it climatological neuroepidemiology, which is a bit of a mouthful, and nobody's going to go for that, which is why I titled the book The Weight of Nature instead of climatological neuroepidemiology. But I think it is only with some semblance of a unified research agenda that we end up with some semblance of a unified action plan. So, first step, I would say, let's ensure that we're on the same page vis-a-vis the fact that these effects are real, and it's going to take interdisciplinary collaboration to articulate some of the basic science at play.
Should we remove? There's a question in the second row, and then we'll move.
Hello, thank you very much. My name is Angela Austin. I've been in the field of dealing with neurodiverse people for 50 years, yes, believe it or not. And what I've noticed is an enormous increase in the number of children, young people, adults who suffer from PTSD, ADHD, autism, dyspraxia, you name it. And there's a lot of also challenging behavior, increase in challenging behavior. So what you're saying makes sense to me. And I have read quite a lot about how environmental factors already are known, excuse me, to affect these aspects of human society. I wrote to my MP today, funnily enough, and asked her how many neuroscientists the government employ to advise them. And one of the things that occurs to me coming out of everything you've said, which I found very interesting, and I agree with an awful lot of it. I know some of it's fact, but the drive to make changes that you talk about, I absolutely go along with it. It's absolutely essential to all of us. But how do we get policy change that will take notice of this kind of research? I know that you're saying you're sort of at the beginnings of it, but it seems to me that this is really at the bedrock. Human behavior is driving these changes, and human behavior is what needs to be addressed through policy.
Yes.
So how would you suggest that governments are persuaded, nudged, however you like to put it,
yes,
to take on listening to neuroscientists like yourself, to create policies that are going to make changes for human beings and the climate that we live in?
It's such an important question. Yeah. And it's a difficult question, but I think, part of what we're talking about here is a suite and a slate of very intimate effects. And I think intimacy, right, emotional intimacy is in part what's missing from the climate conversation, especially at a policy level. It's really difficult to relate, right? Even in terms of the neurological processes at play, right? Our brains were just not built to reckon with 100 years into the future, or even 50 years into the future, right? It's really difficult to empathize with future generations. And we can try all kinds of behavioral tricks to get there. But I would argue that that's actually less important than understanding the fact that the change is already here now, and in fact, it is inside us. It's not about what's happening over there and what's going to happen in the future. It's what's about happening, what is happening today within us. And so, maybe I would consider those of you who are writing to representatives to express your concern in those terms. It's not just that we must kind of parrot the science, the very real science of climate change, back to our representatives and say, I'm quite worried about sea level rise. I'm quite worried about these rising temperatures and the increased frequency of extreme storms. But to me, the statement is also, I've just seen this research that suggests my children are going to be at drastically increased risk of ADHD by preschool if I live through a hurricane while I'm carrying them, right? Or that my parents are, 2x, 3x, 4x, 25x more likely to experience a crippling neurodegenerative condition by age 40 if they're living downwind of one of these blue-green algae blooms. I think that we can equip ourselves with a different kind of science that speaks to the emotional experience, right? That intimate internal experience of the climate crisis, because that to me is which provokes a certain urgency in us as people. And maybe it's not even about telling your own story. Maybe it's about casting it on to the representatives in question, right? Your children will experience this. Your parents may perhaps experience as much. And you, indeed, as a person who may have access to air conditioning, will unfortunately experience these things as well, because what we know is that while indeed something like air conditioning can be quite neuroprotective at that kind of medium length time scale, it's not enough to save the day here. Insofar as if you run to the office or you run to school and you heat up your body, you're walking through a heat wave and then ending up in a climate-cooled environment, it still takes quite a long time to reach baseline. And anybody who has run to catch a bus has felt this. You're still quite warm for quite a while, even in that cool environment. And it is at that moment, right, it is when your body is kind of outside of its homeostatic zone of comfort that all of the behavioral effects in question, all these kind of neurocognitive effects in question tend to manifest. And of course, your MPs have felt this as well. And so this is also a story of them. So my advice would be, to the extent that we can ground the climate conversation in some kind of emotional resonance, some kind of intimate internal set of interactions, as opposed to this nebulous set of future interactions based on the experience of others, will do kind of great work toward expressing a certain urgency of acting now.
Great. Clay, we've got quite a few questions to so the very back first, and then we'll come forward to get everybody in. It'll be quick. The very back, yeah. So we're going to have short questions and short answers.
Thank you so much. It is interesting and worrying at the same time. My question to you is that, thinking from a practical perspective, many of the capitalist and private sector companies are in denial. And since your book is focusing on neurological disorders caused by climate change, it sounds to me that it will later, after a few years down the line, will affect human resource availability or job market. So I was wondering, what do you think this research is creating a foundation for? Is it for building a case for private sector to focus more on sustainability, or is it building a case for more use of AI, given that there will be a compromised human capability in the future?
Let's just take a few questions at a time, because there's 3 in a row. So we just take those 3, and then we can take on to that, and then you go for it. Oh, okay.
Okay. Hi, my name's Eleanor. I'm a therapist, but I also have a background in advocacy, policy, campaign work. And I would just say, totally agree. It's completely how we communicate. It's unfortunately having to do a lot of research to tailor the information to the person's individual needs, wants, and how you can hit it with them personally, of how to communicate with them. My question was around, and I don't know if we'll have time to answer these things, but the pregnancy study, I'm really interested in terms of, there's obviously the kind of neuroepigenetic aspect, but in terms of the environmental factors, once the babies were born, that's obviously then a very stressful environment to be born into, where the constant fear of, well, we've lost home once before, who's to say it's not going to happen again? And I'm just thinking from a policy perspective around, was it part of the research that, hang on, what's my question? To kind of account for that, and like, what would it mean in terms of future planning, where we're not going to act like, oh, we're surprised there's been another hurricane, to forward plan to meet the needs immediately rather than delayed. If that makes sense.
Yes.
So there's one at the very back, yeah. And then we'll take those 3 and then we'll answer them.
Hi, thank you. My name's Alison, and I'm a DPhil student in the School of Geography. And I think my question's kind of related to the other 2. It sounds like you've got a lot of data about like effects that you can expect from different climate scenarios. And I'm wondering, have you made, or has anyone made an effort to kind of value these and do like scenario modeling and look at what these like effects are going to cost altogether and how those effects are going to change in the future? And if people aren't doing that, I'm wondering, like, what are the limitations to doing that? Because I think that's probably quite a good way to communicate with policymakers, is to just give them a number often.
Yes.
So yeah, just wondering if you had thoughts on that.
Yes.
Should we start with the first person?
Sure. Well, let me just briefly offer an answer to you. Was it Alison? The answer is no. Nobody's trying to do this, unfortunately. And I think the limitations are largely a function of an awareness or a lack thereof of the research in question, as well as in some cases a difficulty of valuing some of these conditions. Right? It's relatively straightforward to put a price on the treatment of something like yellow fever, or the treatment indeed of something like Parkinson's disease. Right? That we have cost functions that estimate these costs both to the individual and to healthcare systems. There are many other low acuity mental health conditions that are much more difficult to price. And some of the productivity effects in question, have really, really wide error bars around them. And so forecasting out 20 years, 30 years, 70 years, it's a difficult effort. I would love for somebody to do that. I have done some back of the envelope math, but I'm just a guy. So to the extent that there could indeed be somewhat of a unified research effort focused on those types of valuations, sign me up. I would love to see it. I think it's sorely missing. On the notion that we're at risk perhaps, or indeed seeding some kind of a conversation that leads to a trade-off between human capital and technological capital in the form of AI, for example. I think when I offer a perspective on this field vis-a-vis the AI question, I tend to circumvent it because I wind up talking mostly about outdoor workers. We know, for example, that these same kinds of productivity costs are realized via a wide variety of environmental exposures, including ozone levels, right? If ozone ticks up by 10 parts per billion on a blueberry picking farm, output on that farm drops by something on the order of 3%. You see dozens and dozens of these kinds of studies relating effectively manual labor with environmental conditions. And a large language model can't pick a blueberry. So in that case, we're talking strictly about fiscal margins. We're talking about profit margins that, under capitalism, I believe it is going to be incumbent on the private sector to pay strict attention to. Now, in terms of white collar, right, and service workers, how might we grapple with some of the productivity effects in question? Does this offer grounds for saying, oh, we ought to be substituting human capital for AI capital? Can we correct for some of these effects, or indeed supplement labor with a technological solution, AI or otherwise? I think it's an open question, and we're really just at the beginning of this debate. I would, kind of in a speculative manner, offer that everything we know about neuroprotection, everything we know about recovering or somewhat, supplementing the deficits in question, for example, psychological solutions that would suggest merely picturing a cold environment, icebergs and glaciers and the like, merely picturing snowfall is enough to recover some of the neurocognitive deficits of heat when you are exposed to it. If you strap a cold pack to your forehead, again, that is enough to, without doing anything else to your body, recover some of the neurocognitive deficits of heat exposure. So we have tools at our disposal, therapeutic, technological, indeed perhaps as a function of artificial intelligence and otherwise. We have tools at our disposal that can correct some of the deficits in question. I have yet to see any models out there in the world or any studies that have offered a compelling case that says we can adapt enough to fully offset the losses we expect to see, and that ultimately we're going to need to make more changes than technological stopgap solutions if we want to maintain current levels of health or indeed improve health outcomes amongst workers. I have now gone and nearly forgotten your question. Environmental stress exposures.
Yes. And just a quick one to this we need done.
Yes, okay. Yes, so I'll give you the study, and that'll prevent me from having to prattle on about it now. But in terms of exposures and inoculating folks against the stress of constant threat, it's an active area of research. We know that, so leave Hurricane Sandy alone and look at Hurricane Katrina. This is in New Orleans in 2005, basically the most expensive natural disaster that's ever occurred. Half of low-income people who experienced Hurricane Katrina presented after the fact with post-traumatic stress. And that's relative to about 5% of the population. Those same people were then hit with another hurricane a few years later, and indeed a subset of them had to move a third time as a function of a third natural disaster after that. And constant stress you can demonstrate to continue to exacerbate the conditions in question. It is not something you adapt to. The only way that it appears thus far that I'm aware of that we can adapt to that kind of future threat is through therapeutic techniques that are specifically focused on adapting to future threats of uncertain value. One interesting thing we do know is that among the most climate concerned among us, right, people who express greater degrees of climate anxiety relative to those who express lesser degrees of climate anxiety, and this is correcting for base trait anxiety, correcting for levels of generalized anxiety disorder writ large, and just focusing on the cognitive emotional dimensions of climate anxiety. Those who are most climate anxious along that cognitive emotional dimension are also those who are most likely to engage in pro-environmental behaviors, and indeed those who ultimately are perhaps most resilient against some of the stressors in question. And there's a neurological study that came out just 2 weeks ago that showed these people, you zoom in on their brains, have a smaller area of cortex called the mid-cingulate cortex. It's smaller in these people. And this is kind of a future threat uncertainty processing area. And yet, in addition to it being smaller, which doesn't make a lot of sense, it's kind of a head scratcher, it's more densely connected to a chunk of the brain called the salience network. And this is a series of regions that are effectively responsible for identifying what you ought to pay attention to in space. And so what the researchers argue is that this greater degree of climate concern and pro-environmental behavior, it's actually associated with more efficient wiring between your future threat network and one's ability to attend to relevant threats, relevant stimuli in your present day environment. And so I think the lesson there is, in fact, again, that something along the lines of cultivating a sense of mindful presence, something along the lines of cultivating an ability to grapple with uncertain future threat does appear to have some kind of behavioral outcome suggestive of resilience to the type of stress that we're all going to be under as a function of climate change. But again, kind of speculative. So it's a great question. We're still at the beginning of so much of this. And, I would be pleased to keep my eye on this field for the next couple of years.
Great. I think we have to leave it there. There'll be an opportunity. We can have drinks outside. You can have drinks outside, so there's lots of chance to ask Clayton questions and have a good chat to him there. Also say thank you very much to the online audience. We don't have any questions from them, but thank you very much for joining us anyway. And thank you so much for really an absolutely fascinating and passionate introduction to your book, which I have to say I would recommend strongly. Very easy and wonderful read. So thanks so much for a great talk.
Yeah, thanks so much.